In the opener today, it's really, really important that we keep straight the difference between adding and subtracting square roots like we're doing in the first problem and multiplying square roots like we're doing in the second problem. Okay, they are completely different things, and if we start mixing those up, we're gonna run into some trouble. All right, so let's start with adding square roots. In this problem, if we want to add or subtract, we do have a subtraction here also. Square roots, what's the first thing we need to do? Okay, we're going to start by doing factor trees because we want to simplify these square roots. All right, now keep in mind that there are three terms here. So since there are three separate terms, we have to simplify them separately. All right, so we have to simplify the square root of 45, we have to simplify the square root of 25, and we have to simplify the square root of 20 all separately. All right, and then if we can, we'll combine some of them or maybe even all of them. All right, so we'll start with factor trees. 45, we'll do 9 times 5. 9 would be 3 times 3. 25 is 5 times 5. What kind of number is 25? It is a perfect square, right? So we can use that if we want to kind of simplify our work on that one. So after the factor trees, what are we going to do? So rewriting this, the first square root in the 45 is what? What goes in there? 3 times 3 times 5. All right, the next one, instead of the 25, we have two options, right? Since 25 is a perfect square, we could do 5 squared. So we could either do 5 times 5, like we have in the factor tree here, or we could make it 5 squared. I like doing the square. I think that's just a little bit simpler, but if you want to do 5 times 5 and put that in there, that's fine. You'll circle it, and that'll go on the outside just like the 5 would here. Then we've got a minus square root of 20, so instead of 20, we're going to have 2 times 2 times 5. Now, before we go any further, I just want to point something out. Yesterday when we multiplied square roots, after we did the factor trees, what did we do with all the factors? We put them all in one square root, right? So when we're adding and subtracting square roots, we can't do that because the terms are separate. We have to keep those square roots separate. When we're multiplying, it's all one term, so we can put them all together into one. All right, now what? All right, circle in pairs. We've got a pair of 3s here. We've got a pair of 2s here. And if you wrote this as 5 times 5, that would be another pair to circle. Or since I wrote it as 5 squared, what can I do? Cancel the square with the square root. Notice that the square and the square root are both canceling each other out, so that's just going to leave the 5 all by itself. All right, so another rewrite now. When we rewrite it this time, what's this going to turn into? 3 on the outside and 5 on the inside. Okay, how about this one? That's just 5. All right, I did see a few people put a square root on it, like that. That's bad, right? So the square and the square root cancel each other out. Or if you had it as 5 times 5 and you circled it, since it's circled, it goes on the outside, that means the square root's gone. All right, so make sure we don't have the square root on there. And then the last term, we have minus, what goes on the outside? 2. And 5 on the inside. All right? So we've simplified each of them. Do we have any like terms now that are going to combine? Yeah, which ones? 3 square root of 5 and 2 square root of 5. So if I were doing this problem, I would be tempted right off the bat to say, well, those can combine, so I'm going to do that right away. All right, why do I not want to do those first? So since the 5 doesn't have the square root, that one should go first, right? So when we're writing them in order, we want the square roots, the radicands, to go from smallest to biggest. So the square root of 5s are going to come after the 5 without the square root. I know it's kind of confusing because there's a lot of 5s there, but there's no square root on that 5, so that should be our first term. So it doesn't combine with anything else. That's just going to come down. Do I need to put the plus in front of it? No, why not? Because it's the first term, right? So if the first term's positive, we don't need to put a plus in front of it to show it's positive. If we just leave the sign off, we know it's positive. Then we'll combine the 3 square root of 5 and the 2 square root of 5. The 2 square root of 5 is negative, so what is 3 minus 2? 1. Is that a positive 1 or a negative 1? It's positive, right? The 3 is positive and the 3 is bigger than the 2, so we're going to have more positives than negatives. So we get plus 1 square root of 5. And this answer is okay. I don't mind this answer, but we can simplify it a little bit. We would give you full credit if you put this as your answer. But there's another answer I like a little bit better. Anybody know what it would be? Yeah, take that 1 off. So keep the 5 there, plus take the 1 off, so it would be 5 plus the square root of 5. Again, either one of those would be okay. You would get full credit if you wrote it like this with the 1 in front, but this is a little bit of a simpler answer, so I like that one a little bit better. If you have a 1 as a coefficient, you can just get rid of it. So then the second problem was the new stuff, the stuff we did yesterday, and this is multiplying square roots. All right, so when we multiply square roots, how many terms do we have here? I'll give you a hint, it's not 2. Looks like there's 2 terms because there's 2 separate things here. We're multiplying 3 square root of 12 times 2 square root of 150. But do we have any pluses or minuses? No. Remember, terms are things that are separated by pluses and minuses. So if we go back to the last problem, this is a term, this is a term, this is a term, because we have a plus here and a minus here. All right, but in this problem, we don't have any pluses and minuses separating them, so it's all one big term, which is why we're allowed to combine it like we did yesterday. All right, so what's the first thing we're going to do? First step on your notes says what? Most of you have your notes out. Multiply the coefficient. So we're going to multiply 3 times 2 and get 6. Now, I'm not going to write it directly underneath it, but I'm going to leave a little bit of space because the next thing we're going to do is we're going to do factor trees. All right, so the 3 times 2, we got the 6. Now we're going to factor the radicands. 12 is 2 and 6, or I did 3 and 4, but that's okay, right? Get the same thing. And then how about 150? That ends in a 0, right? So it would be 15 and 10, and then 2 and 5, and 3 and 5. All right, so here's the biggest difference between adding square roots and multiplying square roots. Now what can we do with all of those factors? Can put them all in one square root. All right, so we're going to make one big square root, and all of those factors are going to go in there. How many 2's do we have total? 3. Yeah, we got 1, 2, 3. How many 3's do we have? 2, okay. And then how many 5's? 2. And I didn't quite make my square root big enough, so I'm going to extend it. Okay, now what? Yeah, now it's the same thing we've been doing for a few weeks now. We're just simplifying the square root. So we start by circling pairs. We've got a pair of 2's, a pair of 3's, and a pair of 5's. And then those pairs are going to go on the outside. So on the outside, we've already got a 6. And then we're going to multiply it by 2, which is 6 times 2, 12, times 3, 36. And then 36 times 5? 180. And you can just punch all that into your calculator, 6 times 2 times 3 times 5, and that'll give you your coefficient. That's all the outside stuff, but we do have something left on the inside, the 2.